Okay, let's consider a problem on write back versus write through caches. So let me briefly explain the difference. So in the case of a write through cache, when you have a store instruction that wants to write to a location, let's say X, if you have a cache and you have this main memory, so let's say this is your cache, main memory is over here. So in the case of write through cache, you would not, if you have the block containing the address X, you would modify the cache contents, but you would also write it through to the memory and update the contents of the main memory as well. So at every point in program's execution, the main memory state will be consistent with that of the cache state, meaning you won't have two different values to a memory location when you're using a write through cache. Now in the case of a write back cache, you reduce the number of writes to main memory by keeping dirty blocks in the cache which can make the data in the cache go out of sync with the data in main memory. So for the same example, if I have a store to X, I would modify the contents of the cache, but I may not modify the data corresponding to that same address X in the main memory. Instead, I would set a bit indicating that I have modified this cache block. This bit is what's called as a dirty bit. And now later on, let's say some other instruction happens to bring a different cache block that maps to the same cache line where the previous access had modified, then this block needs to be evicted. It's only when you evict a dirty cache block, it has to be written to the main memory. So when you evict this cache block, you evict the data and then you write it back to the main memory. So the main difference between the write through cache and the write back cache is, in the case of write through, every store goes through to the main memory. In the case of a write back, you cache it as long as possible, and then only when you evict a dirty block, you write anything at all to main memory. Okay, so now let's look at this problem. So in this problem, you have a program that has 2 billion loads and 1 billion stores. And this architecture is a 32-bit architecture, so every load and store writes to 4 bytes of data. And you're asked to assume a cache with a block size 32 bytes and a cache that has a hit rate of 95%. And the question is, we need to compute the amount of data that you're going to read and write from the main memory for 3 different configurations. One with cache, one with the write through cache, one without cache, one with the write through cache, and one with the write back cache. So if you didn't have any cache at all, then every read and every write is going to go to the main memory. And given that every read and write is accessing 4 bytes worth of data, we can simply compute the amount of writes by multiplying the number of stores with the size of stores and multiplying the reads with the size of reads. So the amount of data that is going to be written is 4 billion. The amount of data that is going to be read from main memory will be 8 billion. Now let's assume a cache which is a write through, and we are also given that it is no allocate policy. So for this cache, all the stores still go to the main memory and are still 4 bytes each. So the amount of data that you need to write is same as in the case of a no cache design, which is 4 billion bytes. But you're going to significantly reduce the amount of data that you may need to bring in for reads, because only the reads that miss the cache, you need to bring in the whole cache block worth of data. Now notice the difference here. When you miss the cache and you bring something into the cache, it is the whole cache block that is read from the main memory. So previously, when you didn't have caches, you were only reading as much as you need to execute the read. But in this case, you need to read the whole cache block. But still, you come out ahead in terms of the amount of data that you need to read, because the cache helps you reduce the number of reads that need to go to the main memory. Now finally, let's consider the write back cache. So in this case, we have a total number of memory accesses, which is loads and stores put together. It's 3 billion memory accesses. We'll quickly see why that number is what we need. So when you have a write back cache and you're trying to compute how much data you need to read from memory, and if you're going to assume write on allocate policy, then for both store and load misses, you're going to read block into the cache. So 3 million memory accesses are going to bring in 32 bytes of data. Not 3 billion memory accesses, but the fraction of accesses, but 5% of 3 billion memory accesses will bring in 32 byte worth of data. And now when you look at the data that is written to memory, keep in mind that only when a dirty block is evicted, you need to write anything at all. And so when would you evict a dirty block? That could happen either for a load or a store. So for all memory accesses, whenever you miss the cache, you need to write back if it is a dirty block, which happens to be 25% of all cache misses, and the block size is 32 bytes, and therefore you end up with 1.2 billion bytes.